This is our last video on finding the inverse of a 2 by 2 matrix using a formula. On a previous video, we used reduced row echelon form or elementary row operations to turn our 2 by 2 matrix into the identity matrix in order to find the inverse. But there is an easy formula that we can use after learning what is called a determinant. So we did a whole video on that, and also you had videos that you had to watch from YouTube having to do with finding the determinant of a 2 by 2 matrix. But again, as a reminder, a determinant, it's called a determinant because you determine whether you have a function or not a function. And in this case, it's helpful to know if we have a function in order to find the inverse of a function, because again, what is the point of finding an inverse if we don't have a function to begin with? So again, this is using the determinant formula in order to find the inverse function. So from the videos that you watched, if you have a 2 by 2 matrix, A, B, C, D, written in that form, again, these parentheses here are like the brackets I use for matrices. It's just another way to write a matrix. So if you have a matrix A, then its inverse is using 1 over the determinant formula times D, negative B, negative C, and A. Notice that the order of A and D are switched to D and A, and notice that B and C are the opposites, negative B, negative C. So here is an example of finding the inverse of a matrix that's 2 by 2. This only works for 2 by 2. For a matrix that's a 3 by 3, 4 by 4, etc., it gets a little bit more complicated. And again, we don't need that here in pre-calc, but you will need it in linear algebra if you take that later in the future, but you'll learn it there. So how to find a inverse of a matrix using a formula. So here is our inverse. 1 over the determinant, 3 times 2 minus 1 times 4. Notice that I rewrote the 3 and 2 to 2, 3, and then 1 and 4 become its opposites. So going ahead and simplifying that, we get 1 over 6 minus 4 times 2, negative 1, negative 4, 3. That's a half of that same matrix. And taking a half of each of those numbers by doing scalar multiplication, a half of 2 is 1. A half of negative 1 is negative 1 half. A half of negative 4 is negative 2. And a half of 3 is 3 over 2. Again, you can check to see if it is the inverse matrix by using a calculator. Like I did on a previous video, you got to check A times A inverse and A inverse times A to see if you get the inverse matrix. Here is the website that you can go to. This is that site I told you for the matrix multiplication that you could use. And I went ahead and just used that, and I did get my inverse matrix to be correct. Here's another example. So again, the A inverse, 1 over the determinant times, again, we switch 2 and 1, and then we take the opposites of 4 and negative 3. So 4 becomes negative 4, 3 becomes positive 3, and then writing it in to our formula, we end up with our inverse matrix. 1 over 14 times 1, negative 4, 3, 2. So again, 1 over 14 minus 2 over 7. I reduced negative 4 over 14, got negative 2 over 7, 3 over 14, and then 1 over 7. Again, I went ahead and checked that on the calculator using the same site, and then we did end up with the correct answer. So A inverse is the answer that we got. Here is just additional problems. It's called exercise 1. So find the inverse of this matrix. So here we have 1 over, we're going to write down our determinant, 1 times 2 minus 5 times 3. That's 1 over negative 13 times, remember we switch 1 and 2, 2 and 1, and then we take the opposites of 5 and 3. Here is the inverse that I got. Double check again that it is the correct answer. Again, this is that website that I gave you earlier, and it is the correct answer. I checked both A times A inverse and A inverse times A. Number 2 says, explain why the inverse of the matrix 6, 4, 3, 2 cannot be calculated. So I'm going to go ahead and do the determinant, 1 over the determinant of that matrix, 2, -4, 3, 6. So if we take a close look here and I look at the determinant, notice that the determinant 12 minus 12 is 0, and we know that since 1 divided by 0 is undefined, therefore the inverse does not exist. So if you get a situation where you do your determinant equals 0, you're going to get an undefined answer, and therefore the inverse does not exist. Number 3 says, show that 3, 4, 2, 3 is the inverse of 3, -4, -2, 3. And again, we can do this by using matrix multiplication. So we check that A times A inverse is the identity matrix and vice versa. A inverse times A is the identity matrix. So I went ahead and multiplied my identity matrix to my original matrix. And as we can see, we do get the identity matrix. And I did it vice versa. And I also ended up with the identity matrix. So it checks out. So hopefully this is, again, a little bit more extra problems on how to find the inverse of a 2 by 2 matrix. Like I said, 3 by 3, 4 by 4, all of that. You'll learn in linear algebra when you get to college. For some of you next year, for some of you, a couple of years from now. But that's pretty much it. This is, again, our last video. I do have the last day of work, the 21st, up there for you to do, especially if you are below a 50%. Remember that you have to do all the videos. That includes the last day of work, the 21 days of work. So that's already going to be up there for you, seniors. Again, as a reminder, your work is due May 22nd. As soon as possible. If you could get it before the 22nd, that would be great. That way I can go ahead and bump a letter grade up for those that did what you're supposed to in regards to either if you're above a 50% or if you're below a 50%. Seniors, again, the 22nd, ASAP, because after that, that's pretty much it. For the rest of us, May 28th, that's when work is due. So make sure by 2 p.m. you get that all in. Again, your assignment is on WebAssign. It's just a short little assignment. But again, have a good day.